now let's just move into the second lot, and these are connected, and cloud manufacturing or cloud-based manufacturing, whatever you call them. And I think it's actually, we're talking about new way to run business, new way to run manufacturing business. As I said, I combined these two talks together, so I've overlooked I will just pass the first two sections there. And I talk about service science. Remember, I talk about service. It's a very important concept in my view. And then I talk about cloud manufacturing and how do we define that. I'll give you a couple of examples there, and then talk about some other aspects of cloud manufacturing. And then I'll finish off. So this is, if you like, the second lot of the discussion. Well, cloud computing comes out first, of course. So when you talk about cloud manufacturing, the first thing you think about is cloud computing. The key thing in cloud computing concept is cloud computing services, basically offering things as a service. You pay as you go. I mean, it's a very important concept. It's probably one of the key concepts why it survives for so long. I think it will continue to survive. So you can offer infrastructure as a service and platform and software as a service. And so that's cloud computing service, why they sort of can't be separated. And service science, you can see I have a word science behind service, and believe it or not, service is being considered as a science. This has actually come out of UC Berkeley working with people from IBM. So this is, I think, about 5 or 6 years ago. They view service science as service science management and engineering, so SSME. They have this interesting logo there as well. So this is a science, it's a management science, is engineering as well. So I think they start to offer degree programs on this as well. Well, when we talk about service, we know service in the traditional context, but we can actually trace back to this book published by Professor Daniel Bell, really looking at the industry revolution. You know, this is in 1970s, a long time ago. He's talking about what we are going to sort of experience in terms of the revolution of manufacturing industry. So he's talking about knowledge-based services will overtake manufacturing. Okay, well, it has happened to some extent. And the services in general will swamp manufacturing as a source of employment. Now, the key word is service, but I'm unclear about whether Bell thinks the service here that he's talking about is actually another version of manufacturing business, another version of making products, or it is more sort of traditional kind of service concept. But in any case, service is coming our way, and we cannot ignore that it is becoming a normality here for not just people like us, but also for businesses, for manufacturing businesses. I mean, if you talk about service, there's a different concept that this is the service-oriented architecture borrowed from IT industry, of course. So you have service provided and service requester, and the important thing here is the service register, of course. If you want to coordinate services in a proper way, then provide better service to the requester. This is important. And cloud manufacturing, to a certain extent, utilizes the similar concept. So I think it is quite clear that manufacturing businesses are being transformed from production and physical system-oriented business into service-oriented business. So I think businesses are no longer just producing a physical product and then sell to customer, then they forget about it. it is not happening that way anymore. They're selling a solution to the customer. And that solution has got the actual product, but also service elements perhaps, solution elements in there. So it's a complete package. And the manufacturer will try to still keep the connection with the user that are using their system. Well, there are many, many examples there. In my university, you know, we have staff common room like your common room here. Our coffee machine, we do not own the coffee machine. We didn't buy the coffee machine. We buy the service. So we say, look, we want to, you know, have a coffee serving site, and we have so many people there wanting, you know, using the service. And so we basically, they come and put a coffee maker there. They come and top up coffee beans. If there's a problem, they come and fix it. If there's a new version of the coffee machine, they will come and replace it. We are buying a solution, a service. We are not buying that physical machine. So it is changing, and many, many examples there. So this is important, service-oriented kind of concept. So if you look at this is sort of very conceptual level of understanding about a product. If you're making a product, if you look at which part of the products that's giving revenue to you. So the revenue resource is 100%. You're selling the product or service for that much of cost. And the product itself may have some hardware components. For example, if it's a car, of course, the car itself is hardware-based systems and products. And then you have software-based kind of elements in there. There's intangible services and analysis and monitoring capabilities there. And so I think the trend here is in early days, you know, you can actually sell a product at a good price with very little software components there. I mean, as long as you make a brilliant machine tools, and you know, it can, and people can use them to produce components easily and give a good accuracy, that's fine. But increasingly, this software components is actually overtaking the hardware parts there. I think that's the trend we are seeing. So really, you have to think about this part here. Whatever you produce, even if it's a car, you have to think about this. I mean, in this case, in these days, cars have got a lot of electronics and embedded intelligence in the cars. And the good thing for advanced economy to think about this is also because hardware-based things can be easily copied. You can just strip it down and measure that, and then you can reproduce the system. But if it's a software, unless you have unique skills, it's difficult to copy. It can easily sort of protect your IP in there. So there's a lot of examples of cars, smartphones, and you think about it. And the key thing, of course, is total integration of these two things. They have to come together. So again, that's the thing that we're looking at, and the software-based sort of components really contributing to the service part rather than the actual thing you're buying. Another example is smartphone. These days, this is coming out of the New Zealand web page. You can buy a smartphone for $0, so you don't pay anything for the actual physical product. And you pay for the plan, of course. You pay for whatever plan that you want to buy it with. One extreme, okay, so the actual physical components is zero, worth nothing. And you have to buy the service. And they come together, so that means you can't have one without the other. I mean, you might say, look, I just want the phone to use as a camera. I don't want to use it as a phone. Well, that's fine, but that's probably not what the customer initially designed for. Well, so that's service aspect of this manufacturing. And then how do we define cloud manufacturing in this context? Well, this is my definition. It's published in this paper in 2012. I mean, we're really looking at sort of utilizing cloud computing sort of concept. It's basically looking at a network access to a pool of manufacturing resources. Now, we're actually generalizing manufacturing resources in a broader way. Things like software can be part of a service, and equipment, capabilities, and anything else that you can treat, you can actually sort of offer to other people. These services can be rapidly provisioned and released with minimum management efforts. So it's looking at capturing different manufacturing services and offer that to the customer. So that's the concept. Just a couple of examples there. Manufacturing involves design, so design is often considered as key components of manufacturing business. But design software has been sort of making the headway there, offering as a service. This is what I call low-hanging fruits for cloud technology. Well, there's different CAD systems out there. Autodesk is one of the early ones, still around. They are the first people offering software as a service. This is a design platform as a service, PaaS. So what they've done is you can actually purchase their service online without having to buy annual license, whatever. So the different fleet of their products is product lifecycle management, simulation package, and fusion for 3D direct modeling, and computer-aided manufacturing as well. So it's a pay-as-you-go model that software companies are offering. There's a lot of benefits of doing that. You don't have to invest good computers in your company. You don't have to manage your licenses. You don't pay annual license. Once you have updates, you don't need to sort of go and physically update yourself, because the server will update for you. So there's a lot of benefits there, and they offer different different type of services there. And if you look at the cost benefit here, you pay just under $7,000 for 120 jobs. And if you pay annual license, traditionally that's how much you pay for 1 year plus the maintenance fee there. So it works out. If you only do once or twice, you use once or twice a week, their systems, you're much better off to use that pay-as-you-go model. Unless you say you probably use twice or three times a day and 365 days in a year, and then probably you pay that annual license, that will probably come out on top in terms of saving software cost. So it depends, still depends, but I think attractions are here. In our university situation, we use different packages for our courses, and we only run our courses in 1 or 2 semesters, and even in 1 semester we only use perhaps a particular software for 3 weeks, for example. We don't need an annual license. We only need to pay for 3 weeks of use. So this is actually quite useful for us as well. For normal businesses, maybe it's not the case, but it must be. There will be benefit if it's not heavily used, of course. Well, that's on the software side. This is more sort of on the industrial system side. This is the project that we've been working with a research institute from Stuttgart in Germany. So we're looking at the industrial systems. In this case, these are machine tools. How we can utilize these resources in the cloud to support multiple systems in the factory. So things you might want to do, such as PLC control, robot control, motion control and collision detections, and CNC, of course, as well. Now, the way it may work is like this. We're looking at a cloud-based control as a service. So what we have at the moment is, if you're controlling an industrial system, you have fairly sort of complicated computational parts plus the process parts sort of combined together in the local resources. Maybe it's packaged in a controller on your machine tool, for example. And very often this computational part has got IP there, has got an intellectual property embedded in there, which is probably has more value than just the process part, which is basically a very low level data to communicate with hardware to realize whatever you have calculated and processed. So what we're looking at is can we actually move this out of this local resources to have it in a cloud? Then this can serve other systems. And of course, you have to have some way of communicating with other systems. In this case, you want to communicate with multiple machine tools, for example. So, and once you can do that, then you can offer your service in a cloud to different systems. Now, there are still technical issues that we're working on, of course, and how do you make this happen? Of course, you can't have real-time control through the internet at the moment. And so really the scenario is to have some sort of platform here as a flexible control platform. Then you have plugins for factory functionalities, whatever you want to do. You want to simulations, HMI, and manufacturing execution systems, and ERPs, and others. So the idea is offering a cloud-based platform that house different services, and then you can plug in and coordinate different services. So it's a platform as a service, the way I see that. Now, we've been working on this for some time, but really, what is the catch for industry? And when you go out and talk to people from industry, what do you talk to them? Well, there are two different groups. I think there'll be one group that actually asking for services, and the cloud-based technology will serve well for these people, because you don't have to invest yourself if you can use other people's service. So shifting the capital expenses to operational expenses, and business become more agile as well, and you can have access to innovation in a quick way. For businesses that has got unique services that they can offer, or spare services, capabilities that they can offer, there's also a lot of benefits. They can have access to a large pool of customers if they have it in the clouds. It can improve productivity. This is a better utilization of the resources if you define productivity in that sense. And business is more agile as well. Well, there are actually quite a few things that industry has to look at before they embark on this type of system. First of all, the data has to be sourceable from different places, and so this is from hardware. So it has to be cloud ready, because these days businesses have their legacy systems which doesn't communicate well with other outside worlds. So how do you make sure that the legacy systems can actually give you the data that you need? So this is a lot of work going on at the moment. So we were in Germany visiting Technical University Chemnitz, and they actually looking at retrofitting a machine tool which is 30, 40 years old, and how do you actually put in some simple sensors and then get some data out so you can do some communication. So that's important. The first thing you have to do, of course. And then, of course, the connectivity as well. So it's not just enough just getting data from a system, but also you want to have systems communicating with each other and talk to each other. And I talk about data. You have just too much data, and how do you actually process it and make sure that you have useful information from that. A business may have different resources, and they may need resources from other people, but they also may offer resources to others, and they may want to have, may want to decide what services they want to keep in house and what other services they can offer to other users. So that's actually a fairly sort of business strategic decision that company has to make. Then resources can be offered in a very tight sort of private cloud environments. It can be offered in the community clouds and or public clouds. So there's different options there as well. So business need to think about it. I think we're coming to the end now. Now again, we're looking at very similar structure as the service-oriented architecture there. Here is the here is the user of the services. This is service providers. So we're looking at developing some sort of cloud management system which can actually register the services, and the user will request services from the clouds. You may ask, what do you mean by manufacturing services? What are the resources that you can actually capitalize? You can actually capture and offer as a service. Well, in real sense, anything that happens in the factory can be a service. Can be real resources related things like soft resources and software knowledge, hard resources as well, this is manufacturing resources or whatever, and capabilities. This is sort of at a higher level in terms of what company can offer. And of course, these are all interconnected. And I think what's more important here is these capabilities, when these are captured as a service, which has more meaningful sort of appeal to the customers, rather than just offering a machine tool. Here you go, you can use the machine tools, but what's important is actually package them, offering as a service. I think we're running out of time here. I just want to give you one example here. This is a European Union project funded by a European Commission. This finished in 2013. So it's perhaps the first project that European Commission funded. So this is looking at manufacturing as a service. So it's developed this manual cloud which interact with the manufacturers, getting the services organized here, and the user will interact with the manual clouds, not interacting with the factories directly. So I just sort of quickly show this. I think I just finish off with a few concluding remarks, and I can take on some questions. Well, cloud computing changes the way the manufacturing enterprises do business. I think that's what I want to say. While this cloud computing or cloud technology, I think should also include cyber-physical system concept. It's important really address issues from the industry perspective, and so we need to address the real needs of industry rather than talking about something that sounds good. But business have no interest. They don't want to do. Want to have a bar of it. Well, a few things that's key for cloud manufacturing, or if you like, Industry 4.0. Data connectivity, and I'll talk about that, repeated a few times. Data process analytics and synthesis as well, and cyber-physical system, of course, and Industry 4.0, and smart factories. Well, the cloud concept for manufacturing, I think, is quite sort of unique in a way for countries with many small, medium-sized enterprises, SMEs. This is only true for New Zealand, because the government is looking at sort of setting up a New Zealand incorporated model, meaning we are a big manufacturing company in New Zealand. Let's come together and how we utilize the expertise the different businesses have, so that we can compete. So it's really sort of coordinating resources in a way. So the resource providers and the resource users, win-win situation there as well. And if you can coordinate these different resources together, you can form some sort of virtual enterprise. So you have more capabilities to compete with other people. You have ability to take on bigger projects as well, rather than individual small businesses going out and trying to talk to the big players. So I think that's me. Thank you for your attention. I'll be happy to take questions. Thank you.